Now we're going to look at rechargeable cells. These are the sort of batteries that we can use more than once, because what happens is over time our battery runs down on our phone and then we plug it in and we regenerate the chemicals and we recharge it. So this is things like the lithium ion battery in phones, tablets and laptops, and even cars nowadays, or the sort of nickel cadmium batteries that might be in rechargeable torches, or the lead acid battery that might be in your car. These are all rechargeable batteries. We're going to look at lithium ion batteries in particular, the sort that are in our phones. Now, the syllabus does say you need to learn these equations, and they are a little bit tricky, so it is worth spending a bit of time learning them. They're used because it's the least dense metal, lithium, and so it's very light to carry around. I want you to put a box, sort of in a special extra, I need to remember this box, around these reactions. Maybe put a little star in it, like it's one of those really important to remember things. Okay. At the positive electrode, so this would be the right-hand side, and the negative would be our left-hand side. The positive lithium ions react with this cobalt oxide and make a complex of lithium and this cobalt complex. And then at the negative electrode, lithium is converted back to lithium ions. So at the positive electrode, we look at the oxidation states. Cobalt 4, don't write cobalt 4 plus, it's actually not ionic at this point. Cobalt 4 is reduced to cobalt 3 inside that complex ion. And at the negative electrode, lithium is oxidized to Li plus. Discharge, remember, is the overall when the reaction happens as written. Now they've both got one electron in. If you have a look at this, and I'll just do some working out, the electrons will cancel when I combine this, but so will the lithium ions, because it's used at the positive electrode and produced at the negative electrode. It doesn't need to be replaced. So our overall equation is going to be lithium plus cobalt COO2 makes, oops, Li plus bracket COO2 minus. I'm just going to undo my crossing out and just write a little note at the bottom. Li plus is used at the positive electrode and produced at the negative electrode. It's our electrolyte. It doesn't need to be replaced. The cell, when I want to recharge my battery, all I need to do is apply electric current and reverse this reaction. So the recharging equation is the reverse of the discharging equation. So if you get asked for the recharging, just remember you actually have to do the more negative one forwards and the more positive one backwards. So you just need to be that tiny bit more careful.